In section 3.3 day 2, we're going to talk a little bit about identifying transformations on log functions. Not that we have to have transformations to be able to graph these by hand, but it's certainly helpful in a lot of situations. But then also, we are doing transformations in every chapter just to see, how it affects each function, basically in the same way. Now, I want you to remember the order of transformations as we've had them for all functions so far. The order is important in a lot of ways. First of all, we start with the horizontal stuff, and that means either reflections or stretch and shrink. Remember that those two are basically on the same step, so you can flip those around if you want, but shift, the left or right, definitely does have to come after that. Once we get done with all the horizontal transformations, then we start on the vertical transformations, and they follow the same order as the horizontal. And so we get that order for all the different transformations, and this works for any graph, any kind of function, and it's really simple because this is just the order of operations. So we got a few examples down here, as you can see, for transformations, and we're going to just take a look at each one in particular. Now we've got this is kind of the most basic form of it. We just have x minus 4 on the inside, so we start inside the parentheses, order of operations. This is horizontal. This is going to mean right by 4, and then the plus 2 means up 2. You probably remember that quite well. Moving on to this one right here. This one is where it gets a little bit tricky because now we have some stuff going on inside but not out. Remember that the inside stuff is horizontal, and that's the stuff that could be a little bit different than you might expect in many cases. Let's start though with the simplest one. There's a negative right there. That means a reflection over the y-axis. We don't usually have a reflection over the y-axis with the functions we work with, but whenever it's inside, whenever it's right on the x, then we are talking y-axis reflection. Now the other one that we have here, there's a 2 in front of this x, and I want to remind you that when we're talking horizontal stretch and shrink, we need to make sure that we rewrite this 2x in terms of a fraction, in terms of division. So I'm going to think about this as x divided by 1/2. It's got to be in that setup in order to tell us anything about horizontal stretch or shrink. In this case, we're dividing by a fraction, so that means that it is a shrink. It's a horizontal shrink by a factor of 1/2, and so there are just those two transformations in this one. Now we're on to the third one, and this one has actually a total of 4 different transformations to look at. Like usual, we start on the inside. Now, the thing that's weird about this one is that's different from what you saw in number 1, for instance, is that we had x minus 4. Here it's 2 minus x, and that doesn't look a whole lot different, but it actually means that the negative is now on the x. So that will tell us that we're starting with a reflection over the y-axis. Just like the last one, when the negative comes in front of the x, it is a reflection over the y-axis. So that will flip this thing, make it go the other direction instead. Then we have to decide what the left-right stuff is. Now remember, we always think about what makes this quantity equal to 0, and a positive 2, if we put that in for x, will make that equal to 0. So this is going to be right by 2. Now we work our way to the stuff that's probably a little bit more straightforward. This 3 on the outside here, multiplying the function by a 3, means that we have a vertical stretch by a factor of 3. And then plus 5 is probably our simplest one of all. That just means up 5. So those are the transformations, and they are in order. Now there is a chance that some of them the order could be flipped around and it wouldn't make any noticeable difference. But if you want to be safe on each and every one of them, then use this order, and you'll always have the correct order of the transformations.